So one of the applications of psychrometry is the dryer. First, we'll define some terms here. We have this hygroscopic materials. This is the substance which are particularly variable in the moisture content. And we have the bone dry weight, or BDW. This is the final constant weight reached by a hygroscopic substance after being dried out. And we have this formula of our moisture content. This is the equivalent of weight of moisture over the gross weight. And we have this gross weight. Gross weight is the bone dry weight plus weight of moisture. Okay, so considering this diagram here, we have state 1, state 2, state 3, state 4, and state 5. We have this heater and we have this drying chamber. So we have fresh air entering at point 1, that is in kilogram per second. We have mass of kilogram per second, and point 1 passes through the heater, then the heated air at point 2 entered the drying chamber. So at point 3 we have this humid air out, and we have at point 5 we have this dried product. This is the BDW5. And this at point 4 we have this wet feed, or this is the BDW4. Okay, so by looking at the psychrometric chart in here, we're able to illustrate the process of the dryer in our psychrometric chart. Okay, so we have this point 1 to point 2, and that is equal humidity. Okay, equal humidity ratio, and point 2 to point 3. So we have that as the isothermal dryer, and this is the best dryer. And if in here you have this one, let's say this is 3 prime, this process is called the adiabatic dryer. Adiabatic dryer. And this process from 2 to 3 double prime is non-adiabatic dryer. Non-adiabatic dryer. Okay, so given this process, we have the best dryer is the isothermal dryer. Okay, at point 3 we have this humid air out. So point 1 is this is the dry bulb temperature in here. dry bulb temperature. So it is heated to point 2 here. So this is dB1 and dry bulb temperature dBt2. Okay, if this is straight vertical line, 0.2 to 0.3, that is our isothermal dryer. That is our ideal process. Okay, and it is, when we say it is ideal, that is the best dryer that we have, or the best process that we have, since we consider reversible, because it is isothermal, means of constant temperature. The process is of constant temperature. Okay, and we have adiabatic dryer when Q is equal to 0, and non-adiabatic dryer when we consider heat. Okay, so by looking at, we can have this equation. Have this moisture removed from the material. Moisture removed from the material, this is equal to moisture absorbed by air. Moisture absorbed by air. So this is equivalent to MA W3 minus W2. This is in terms of kilogram per second. Okay, and therefore this is equivalent to M4 minus M5. M4 minus M5. Okay, also we have here the bone dry weight or wet feed. Bone dry weight of wet feed. And this is equivalent to the bone dry weight of dried product. Bone dry weight of dried product. Okay, so we have here BDW4 equals to BDW5. So the bone dry weight of wet feed is equivalent to bone dry weight of dried product. So BDW4 is equals to BDW5. So by looking at our figure, BDW4 is here. This is the wet feed is equivalent to BDW5 of our dried product. Okay, so another thing, we have this one, heat supplied in heater. Heat supplied in heater, you have this MA times this enthalpy 2 minus enthalpy 1 This is in terms of kilowatts. And we have lastly the efficiency of the dryer. We have the heat absorbed by materials over the heat supplied. By materials over the heat supplied.